doing today is gonna be part of the general course, and it's gonna be, what do we have here? Modular Arithmetic 1. So it says, imagine you lean over and look at your cryptographer's notebook. You see some notes in the margin: 4 plus 9 equals 1, 5 minus 7 equals 10, and 2 plus 3 equals 5. At first, you may think they've gone mad. Maybe this is why there's so many data leaks nowadays, you think. But this is nothing more than Modular Arithmetic Modulo 12, albeit with sloppy notation. You may have not been calling it modular arithmetic, but you've been doing these kind of calculations since you've learned to tell time. Look at those equations, and then think about adding hours. So let's see, add hours. 4 plus 9 is 13, so that's 1. So that's 1 p.m. 5 minus 7, take out 5. Then the other 2 is 12, so 10. 2 plus 3 equals 5. So formally calculating time is described by the theory of congruent. We say that two integers are congruent if m modulo, if a is mod b mod m. And I think another way of saying this is that when we divide the integer a by m, the remainder is b. This tells you that if m divides a, this can be written as m forward slash a. Then a is congruent modulo mod m. And calculate the following. The solution of the two integers x, y you obtain after reducing by modulus is the smaller of the two integers. So we have to find this. So what do they mean by, I guess, congruent modulo? So I was having a tough time trying to understand what they mean, but if you just, I guess, Google congruent modulo, you could look up an idea on what they mean where they imply what they're meaning, where if a modulo b mod n and then b equals c mod n, then you could basically interchange the values of a. A could be c or yeah. So we could look at all the images. Yeah, so there's symmetry between these, how you could interchange them. So symmetry, that's the one that we want to look at. These are the properties of congruence modulo. In this case, a b mod n, but you could flip it where a and b could be flipped. In this case, we're gonna flip 11 and x and y and this large number right here, because it's part of the property of something's if something's congruence modulo. You could flip a and b and a. In this case, we're flipping 11 and x and this huge number and y. And all you simply need to do is take the mod value and then whatever the remainder is. So you could probably open up a Python program, Python 3 interpreter. We could open up an interpreter and then just do the modulus of this. So it'll be like min. We want to print out the minimum values between 11 mod 6 and 814567 mod 17. Now if we run this, we should get 4 is the answer, and it says the solution is the smaller integers of x and y you obtain after reducing by modulo. And if we see that, the flag was 4, in which case we got it from right here, which was 4. It prints out 4. So with this, I guess percentage sign is basically a modulo sign in Python. And right here, that's all we did. We simply got 11 and 6, and then the big number modulo 17. And after that, we ran the min function, which is then gonna calculate which of these values is the smallest one, which was part of the requisite right here. The solution is the smaller of the two integers. And after that, we simply ran a print function to print out the values. And the only reason I came across this solution is because it says a congruent modulo. So it's asking us to find the congruent modulo, and they gave us this. Congruent modulo are noted like this. And if we see this notation right here where A, B mod M. And if you go back to the theory, congruence modulo of n is an equivalence relation, meaning it has properties, and one of the properties is symmetry, where you're able to swap out B and A. In our case, we were able to swap these out and just solve this challenge. So yeah, that's about it. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.